Hello, my name is Trung. I'm an amateur astronomer and astrophotographer based out of LA. In this video, we're going to cover how to download and process the raw image data of Eagle Nebula. We'll be using data captured by the Las Cumbres Observatory, which operates a vast global network of large scientific-grade telescopes. For processing the data, we'll be using DeepSkyStacker, Siril with the StarNet version 2 plugin, and GIMP. These are all free, and I'll be providing the links under the description where you can download and install onto your computer. Now, in the heart of Eagle Nebula lies a distinct structure of gas called pillars of creation. This was made famous by the Hubble Space Telescope back in, I think, 1995 when it was processed in the SHO Hubble palette. What this means is you have S2 for sulfur, HA for hydrogen alpha, and O3 for oxygen, hence SHO. Uh, these are the different kinds of gases that are ionized by energy from nearby stars, and that causes them to glow in very specific colors. Now, the problem with sulfur 2 and hydrogen alpha is that in the true color representation, they both emit light in the same sort of the same reddish portion of the visible light spectrum. So when you look at the picture in true color, it's going to be difficult to distinguish one gas from the other, and so you lose a lot of detail in true color. To solve this problem, NASA presented pillars of creation in false color by reassigning hydrogen to green, which is normally red, and then oxygen to blue, which is normally a mix of blue-green, and then sulfur to red, which is normally red, so essentially leaving that one alone. Um, so in this video, we're going to be doing pretty much the same thing. So let's get started. So first thing we're going to do is visit lco.global, which is the official website for the Las Cumbres Observatory. You could type archive in the search bar, hit enter, and in the first result, you click on that. And so that's going to take you to the archive documentation. From here, you click on Archive UI, and this is the portal to the archive. So it looks like the default date range is from August 1st of 2024 to January 31st of 2025. As of now, we're in the 27th of October, so already there's over 50,000 rows of selection to choose from. Now that's kind of intimidating because there's so many. So we have a set of filters that we could use to narrow down our search. Now, we know that Eagle Nebula is M16, so we'll type in M16 in under object and see if we get any returns. So we do have a return of 104 rows. We could narrow down our search by selecting the reduction level to Banzai. What that is it's a pipeline that calibrates the image files, which is what we would want. And then next, this might be useful or it might not, but we'll give it a shot anyway. So under observation type, we'll select expose, which is capturing the image data, which is what we would want. And then next, we're going to filter down the filter. H alpha is a good start. Now that gave us only two returns, and that's probably because of the date range here being too narrow. So we're going to click here to expand this selection here, and we'll try to go back to, oh, I don't know, maybe the beginning of 2024. So January 1st, all the way to, let's go to November 1st of 2024. Now this gives us four rows, which isn't a lot. So we'll try something else. Instead of M16 for the object, we'll type in NGC 611, which is the alternative catalog number for Eagle Nebula. And by doing that, we now have 11 rows. From here, you could click on the plus sign to look at the preview. There's also some calibration files. You don't need to worry about that. It's already applied to the expose file, which is the file that we're interested in. You could go ahead and click on all the plus signs. You know, it's probably easiest to start at the bottom and work your way up. There we go. And then you could quickly preview all of the images and see that they're all the same except for one. This is a different set of data, and it looks like it's because it's from a different observatory, and you know it's a different observatory by the lettering here. So OGG is different from the LSC. These are observatory sites, and it looks like the majority of these are LSC. This is an observatory based out of Chile. So we'll be using data from that observatory. So we could further narrow down our filter by selecting LSC. Okay, there we go. So once again, you could click on the plus sign just to make sure that these are all the same set of data or the same data from the same imaging session. And you could also tell by the date of the image capture. So we have here May 19th, 2024. And to select all of them, just check on this box and then click download. Okay, now that's downloaded, we could go ahead and rename the zip file. I'm just going to add underscore HA for hydrogen alpha because that's the filter that we selected for this set of data. Okay, and then next we're going to switch the filter to sulfur 2 or S2, and that gives us 10 rows in the results. And we'll click on the plus sign to quickly look at the previews. And they all look the same or similar at least. So we're going to check on this box here to select all. Now there's a little problem here. It says download 20, but then there's only 10 files here. That's because we did not clear the previous selection. So we're going to hit X to clear all of the selection and then check on this box again. Now it says 10. So that should be the correct set of data to download. So I'm going to click download. Okay, so now that's downloaded. So we'll go to that zip folder and we're going to rename underscore S2 for sulfur 2. Okay, and then we're going to need oxygen 3 data. So we'll switch the filter to O3. That gives us 10 rows. Now I'm going to clear the previous selection by clicking X, and then I'll click on the plus sign to look at the previews. And they all look pretty much similar. So I think these are good for us to download. So I'm going to check on this box to select all 10 and then click download. Okay, our download has finished and we'll rename the zip file or the zip folder. I'll just add underscore O3 for oxygen 3. Okay, so the next thing we're going to do is unzip these files and then organize them in whichever folder you desire to put them in. The next thing we're going to do is open up Siril, and then I'm going to navigate to the folder location where I organize all the downloaded and unzipped files. We'll first work on HA data, hydrogen alpha. And for these 10 fits files, I'm going to drag and drop each one of them. I'll start from the bottom. So I dragged it into this workspace. And if you're curious to know what this looks like, this is the unstretched linear data. And we could do a preview of a stretched image. And this is what the data looks like when it's stretched. Now, we're not applying the stretched process to the image yet. This is just a preview of what that image would look like. And then we're going to click Save. And that converts the fits.fz file to a fits file. Which would then be readable by the following program that we'll be using next. So we're going to do this for the rest of the 9 of these files. Drag and drop, that's the next one, and then click Save. And just keep doing this until you're done with all 10 of them for the HA set of data. Okay, I've converted all 10 of the files from fits.fz file to just fits files. These are the ones that we're interested in using in the next step. We still need to do this for the other set of data, the O3 data and the S2 data. So just do the same thing. And then the next thing we're going to do is open DeepSkyStacker. On the upper left, you'll see Open Picture File. We'll click on that. And then navigate to the folder where you've done the conversion of the files to FITS files. We'll do one set of data at a time. So we'll start with the HA data, sort by type, and then select all the FITS files from here to here. Click Open. And then after that, click on Check All. And that checks all the boxes here. That tells us that we have 10 light frames. Then we're going to click on Register Checked Pictures and click on Advanced. This is the star detection threshold. I'm just arbitrarily selecting a percentage, in this case 17%. Then we're going to click on Compute Number of Detected Stars. That gives us 8 stars. That's not too many, but we'll try using that threshold for our registration. We'll click OK. And now it's going through the 10 files to make a determination of the number of stars, the measurement of how pinpoint the stars are, which is the full width hat maximum or the FWHM. And it also gives a scoring of the files. The higher the number, the better the data. So let's sort by the number of stars. We'll click on that. We'll click on this one here, which has the most number of stars. Maybe increase the size of the view. Now it's pretty dark here because it's not stretched, it's in linear mode. What we can do here is on the upper right corner, you could slide the mid-tone marker. So this is the dark tone, the mid-tone, and the upper tone. So we'll just make some adjustments here until we see some details here. Okay. And if you put your cursor over the image, it sort of gives you a magnifying glass so you could take a closer look at inspecting the image. In this case, we're looking at the stars to make sure that they're nice and round. This looks okay, and that's expected because we selected the highest scoring file. Okay, so let's increase the size of the preview and we'll inspect each of these images. So when it's highlighted blue here, that's what's being displayed. And you could just click on the row and then use your up and down arrow key to go through these. And I'm just going down one at a time while looking at the image here, just to make sure that the stars are not egg-shaped or comma-shaped, which would be indicative of a tracking problem of the telescope. And that would be bad data or unusable data. But in this case, they all look good. So we're going to use all 10 of them. Um, Now, if we were to stack this set of data, it's going to stack some, but not all of the images here. So if we go to the smallest threshold at 2% and calculate stars, we see 48. So that will give you a higher chance of stacking all 10 of these images. So we're going to go with that. And now our star count has increased. So now next we're going to stack the check pictures. So we'll click OK. So this is our stacked image. We're going to save the image by clicking Save Pictures to File, and we'll put it in the appropriate folder. That was a set of HA data, so we'll go to the HA folder, and I'll just save it right here. I'll call it LCO for Las Cumbres Observatory underscore NGC 6611, which is the new general catalog number for the Eagle Nebula. And then I'll put underscore HA. And then we'll save as type TIFF image 16-bit. Then we'll clear the list. Do you want to save the changes? No. Click on Open Picture Files. And then we'll do the stacking for the next set of data, we'll do 03 and select all the fits files. Check all. So now all 10 frames are checked for the light frames. Then we'll click on Register Pictures and click OK. And then we'll stack the pictures by clicking on Stack Check Pictures. Again, we see here there's 10 frames, total just about 10 minutes. This is what we want, so we'll click on OK. And then we'll save this stacked image under 03. I'll call it LCO underscore NGC 6611 underscore 03. And then clear list. And then we'll work on the last set of data, the S2 data. Select the fits images. Oh, first we need to check all and then register. I'm just inspecting them just to make sure they look good, and they do. So I'm going to stack them. Now, Siril also has the ability to stack these images, but I like using DeepSkyStacker because I find that the graphical user interface is easier to use, and I do like how it gives you the scoring of the images so that you know if there's one bad one, the score is going to be very low. You could easily preview that image and then uncheck the box for that image to omit that image from being used for stacking. Okay, so we're going to save this picture. LCO underscore NGC 6611 underscore S2. Okay, so we're done using DeepSkyStacker. So we're going to go back to Siril and we'll go back to the HA stacked file. You could drag and drop into the Siril workspace. And notice the picture is a lot cleaner when you stack. So this is what it looks like. Here, let me zoom in. And the details are just astounding. Remember what it looked like if you looked at just one image? This is what one exposure file looks like when you don't stack it. It's a bit noisy, it's a bit grainy, which is normal for a somewhat of a long exposure. In this case, a 60-second exposure. You have things like image sensor noise, random noise, hot pixels, and you could minimize the noise by increasing the SNR, the signal to noise ratio, by stacking a few images. And the more images you stack, the better the signal to noise ratio, which means the noise would get lower and lower as you increase the number of photos, as you increase the number of images for stacking. So let me reload the stacked image. See how much better that looks? So that's the power of stacking, which is what I highly recommend doing. Okay, so recall that this is a stretched image for preview, so it's not actually stretched. This is just a stretch for preview. If you want to put it back to linear mode, you go here and click on linear. Okay, and now let's do an actual stretch of the image. And to do that, you click on image processing at the top and then histogram transformation. This is the icon to apply the auto stretch to the image. So we'll click on that. And there you have it. So the auto stretch is essentially pulling out the details that are close to the black portion of the histogram. So if I hit reset, that's the original linear image. And you could manually stretch by pulling down the mid-tone marker here. And then I'll click on apply. And I'll keep doing this until the details emerge. Let's keep going, and I'll click apply again. So this is a simple way of stretching the image. It's not the best method to stretch the image. There are more advanced methods of doing stretching, but we're not going to cover that in this video. This video is intended for beginners, so we'll do the easiest process that we can possibly do, but at the same time yield excellent results. So I'm going to click Reset and then click on the Auto Stretch. We'll use this, so we'll click on Apply. We'll close that. Then we're going to remove the star and create a star layer by going to Image Processing, Star Processing, and then StarNet Star Removal. We'll make sure to have the star mask, so let's keep that checked and then execute. Okay, so StarNet has completed, and that will generate the star mask file and put it in your pictures folder as default. Okay, so let's save this starless image of the hydrogen alpha file by clicking on the down arrow. And I'll navigate back to the same folder where we keep these files here. And I'm going to name the file LCO underscore NGC 6611 underscore HA underscore starless, because there are no stars in this image. And we'll switch to 16-bit just to keep the file small, and we'll leave the compression none. Okay, and then let's move on to the next file, which is O3. Drag and drop. And we'll do exactly the same thing as what we did with the HA data. So that is, we go into image processing, histogram transformation, and then auto stretch, and then apply. Then we remove the star and create the star mask by going to star processing and then star net removal, and then making sure generate star mask is checked. Then we click execute. Okay, and then here's our starless image. We'll save this image by clicking on the down arrow button, and then we'll navigate to where we keep all the files for this particular project. And I'm going to put starless at the end here, just to know that this is the starless image. And we'll switch the format from 32 to 16-bit unsigned integer. Then we'll do the same thing for the final stacked data, which is the S2 data. The auto stretch again, and star removal. Generate star mask. Okay, the stars are now removed. I'm going to save this image, navigate to the appropriate folder, and I'll reuse this file name, except I'm going to add underscore starless at the end and switch it to 16-bit. Now it's time to move on to GIMP. Now, GIMP is somewhat similar to Adobe Photoshop, so if you have any experience using Photoshop, then you might find it comfortable using GIMP. If not, that's okay. I'll show you the very basics of using GIMP for this exercise. So we'll start by going to Files, Open as Layers to open our starless images, and then navigate to the appropriate folders. We'll start with HA and select our starless image of hydrogen alpha. And then we'll also open the other starless image, O3. And the sulfur 2, the S2. Now over to the right-hand side, you'll see the three images that we have here. These are called layers. So we have three layers here. And these boxes here, the first row of the boxes is what we really need to use. When you click on one of these boxes, then you'll see an icon of an eye, and that means this is what is visible in this view. Let me zoom in here. You zoom in by pressing Control and then scrolling your mouse to zoom in and out, if you don't know that yet. Now, if you click on the eye icon for the next layer here, This is what you see. This is the top layer. If you turn off the eye for the lower layer, nothing happens. That's because this next layer is on top and it's blocking the view of the next layer. Now, if you want to convert this middle layer to be transparent so that it blends with the next layer down here, you would then select this layer to change the mode. Now, the mode here is normal. If you change it to screen, then it becomes transparent and it's going to blend with the next layer down below. So if I uncheck the layer below, you could see that there's a change in the view here. So what I'm going to do is change all of the modes to screen. The one in the middle is already screen, and I'll change the bottom one to screen because later on we're going to add stars, and so we need all of these to be screens to make them transparent so that the star layer would be visible through all of these layers. Now, next, we're going to colorize these layers by going to the image pull-down menu and then mode, and then we're going to switch the mode from grayscale to RGB for red, green, and blue. We'll colorize the sulfur data, the S2 data, by going to the colors pull-down menu and then colorize. Click somewhere here in the color section and bring down the blue all the way down to 0, the green all the way down to 0, and then red, we'll type in 50, which is the midpoint here. So 50 for red, 0 for green, 0 for blue, and we'll click OK. And we've now colorized the sulfur 2 data red. Now next we're going to colorize the oxygen data, O3 data, to blue. So we go to colors and then colorize, click anywhere in here, and then bring down the red and the green to 0, and then adjust the blue to 50. Click OK, and then move on to the last layer here for hydrogen alpha, and we'll color that green. So red goes down to 0, same with the blue, and then adjust green to 50. Okay. Now, there's no such thing as up or down in space, but we humans tend to have a pareidolia of things. So when we look at pillars of creation, which is obviously this portion of the Eagle Nebula, they appear to look like pillars, right? And so when we think of pillars, we think of them as columns, like Roman columns of ancient Roman buildings. So if we wanted to change the orientation of the image, we could change just the preview of this image by going to Views and then flip and rotate. We'll do a rotation here. First, we'll try going 90 degrees counterclockwise and see what that looks like. That looks more familiar, but if you know what Pillars of Creation looks like from NASA, it's actually a mirror image of this. So let's reset the flip and rotate, and then let's do a vertical flip, and there we have it, a very familiar view of Pillars of Creation. Now, from this point on, it's going to be more of a subjective, artistic set of decisions that we'll be making to make this image aesthetically pleasing. Now, already you could see that there are very fine details that are easily seen or somewhat easily seen because of the false colorization, as I mentioned before. In my artistic mind, I would say that there may be too much green in this picture. So what we're going to do is select the green layer, which is already selected here. And then we're going to go into Colors pull-down menu and then Curves. And then we're going to bring down the curve just a little bit until more of the blue starts to show up and more of the orange-red hues also show up. So maybe right about here. And there's a preview box here that's checked. If you uncheck it, this is what it looks like before, and then this is what it will look like after once we click OK to commit to the change. And I'm fairly happy with how this looks, so I'm going to click on OK. And then we'll sort of zoom out to look at the overall picture. Now, it seems like the darker area of the image, like right around here, and even down here and here, it's sort of purplish, and that's because there may be a little bit too much of the red and the blue that's overpowering the green in the dark areas. An approach that I'm thinking of doing is selecting the red channel and then going into the levels adjustment under the colors pull down menu and then sliding the dark tone control. So this is the dark tone control, the mid tone, and the upper tone. So we're going to slide the dark tone to maybe right about here. And I'll click OK. And then I'll do the same thing with the blue channel, maybe right about there. Okay. And then we could uncheck all of the eyes and just look at one channel at a time just to make sure we're not clipping the blacks. What I mean by clipping the blacks is if you were to, I'll give you an example. Let's go to the green channel here because the quality of the data makes it easier to see. But um, the darkest part of this image is, I would say, maybe right about here or here. So let's zoom into the darkest areas here, and you can see it's not completely black. There's some signal here. It's almost completely black, but not quite. If you were to over adjust the dark tones in the levels, this is what it would have looked like. And now it's completely black, and that would not be good because we've essentially rubbed off all of the dark, delicate details that would have been in here, and it would not be recoverable in the next process. So that's what we want to avoid. So let's put this back. Now, if I zoom out, you could see there's this delicate wispiness of gas around here, even right here too, and also right here. This is what we want. So let me hit cancel and check all of these layers to be visible. Now, I still think that the background is too much purple in this area and in that area. So to fix that, you could go back to the red channel and perhaps we'll play around with the color curves adjustment and sort of drag the line down to maybe around here. And we'll click OK. Then we'll do the same for the blue channel, maybe somewhere around there. And I think that's a good look. I'll click on OK. Now, I don't think we're done yet. I feel there could be more red in the midtones, which you could see is sort of like around this region here. So we'll go back to the red channel, open up curves, and we'll bump up the middle part of the curve. Now, that sort of looks good in the mid-tone, but then back in the dark tone, the red has come back with a little too much red there. So I'm going to put a point in the lower portion of the curve to bring it back down. Maybe adjust the mid-tone just a bit. This might be in the right step forward, so I'm going to go with this, and I'll click OK. Now the image is kind of coming together. I sort of like how this is coming along. There's a bit of a balance between the blue, the green, and the red. But if we zoom in, you'll see that the red channel is a bit noisy. And let me turn off the view for the green and the blue channels. You can see, yeah, it is indeed noisy. So we could fix that by using noise reduction. So we'll click on Filters, Enhance, Noise Reduction, and maybe adjust the strength to maybe 8. I think that's okay. So now let's add the stars to this image. So we go to File, Open as Layers, And if you recall, after using StarNet in Siril to remove the stars, it created the star masks and placed them in the pictures folder. So we'll go there, press and hold down Control, and select all the star masks here and click Open. Okay, and then next we're going to move the star masks to the bottom of the layer list here. So now let's inspect the star masks. Uncheck the red, green, and blue layers, and now we have just the stars. Seems like the star layers is adding a bit of reducing a bit of contrast to the entire picture. So if I remove all of the star masks, you can see we have a dynamic appearance to the image. If we add the stars to the image, we sort of lose that dynamic, and that's because of the black levels are quite high in each of these star masks. So we could correct that by selecting one star mask at a time and then going into levels. Let me increase the size of this window here so you could see on this histogram, there is a histogram signal here. If we adjust the dark tone right up close to the histogram signal, but not go past it. If you go past it, then you end up clipping the black levels. But if you go close to it, maybe right about here, then I think that's a good step forward to fixing this issue. So we'll click OK. And then we'll do the same thing with the next star mask, right about here. And we'll do the same for the next one as well. Click OK. And now if we bring all of the layers into view, oh, we still need to set the mode to screen for each of these star masks. So I almost forgot to do that. So let's go ahead and do that now. Set from normal to screen for this star mask. And we'll do the same for the next one and for the next one as well. And we should probably disable the starless layer. Now the star seems a bit prominent with all three enabled, and that could take away the focus from the actual nebula. So what I'll probably do is disable the star mask for S2. That sort of tones down the stars, and I sort of like the way that looks. I feel like we could further enhance the nebula. Let's try increasing the blue channel. So I'll highlight the blue channel and go to curves, and perhaps I'll bump up the midtones just a bit, maybe towards the upper tone. I've added a secondary point towards the dark tones just to keep the darks from being too blue, maybe somewhere around there. So I'll click OK. And let's see if I could further enhance the green channel. So I'll select the green channel, colors, and then curves. Perhaps I'll put a point somewhere in the middle tone and bring it down just a little bit. I added a secondary point towards the dark tone just to retain the green signal there. And that sort of looks good to me. I'll click OK. So I'm not going to bother colorizing the stars. If you notice in the original Pillars of Creation image by NASA, the stars are a bit purplish. Um, that's sort of the effect of colorizing the stars when the star data was captured through the S2, the O3, and the HA data. If the stars were captured in typical RGB filters, that would have been a different story. In that case, I would have colorized those stars. In this case, we don't have that type of star data, so I'll keep them monochrome. By keeping the stars monochrome, the stars would not steal some of the focus away from the nebula. In other words, in this picture, I want the nebula to be the highlight of the picture, not the stars. So um, that's sort of the reason why I'm not going to colorize a star to make those pop, and then also not using the S2 star mask. Otherwise, I feel like if I do use it, it's the stars are just too overpowering. So let's uncheck that. I think this is good, so I'll call that done. So let's go ahead and export the data. And I think I'll save it under this folder here, and I'll call it LCO NGC 611 final because we're done with it. You could save it as JPEG so that it'll be compressed to a smaller file size so it's easier for you to share in social media or email it to your friends and family. So we'll click on export. And here you get to choose what quality you want to save this image as. 90 is a good number to keep the file size small, and you could leave everything else as default. And then we'll click on export. And there you have it, the final processing of the image of Pillars of Creation using data from the Las Cumbres Observatory. So a special thanks to Las Cumbres for providing this data to the public, along with thousands of other data that could be downloaded from the archive. Anyway, I hope you find this video helpful and informative. Again, this is just a basic tutorial for beginners to get started on downloading and processing data to an aesthetic pleasing image while preserving scientific data. So thanks again for tuning in and following along. This is your host Trung, wishing you the best. Take care and keep looking up. Bye bye.